Now I just want to basically write few things before we go forward from this. First of all, just write a note here, which is very important. And the note is that the sun is highest above the horizon at noon, which is 12 p.m. Okay, and then in the northern hemisphere, the daylight hours are longest up until roughly the 21st June. Now this day of 21st June is basically called the summer solstice. Alright kids, it's spelled as SOLSTICE. It is when sun is at its highest point in the sky all year, like that. Then kids,
So what does highest point mean?
which means it's like here, see here, above you. Do you get it?
So, so sir, when it's high, does the shadow change a bit?
It means at this point, it is about, it will be the longest day in the whole year. You get it?
Yes.
About 21st June it is. And then you guys need to remember that the daylight hours then decreases to their lowest around 21st of December. So remember that this date, 21st December, this day you have it is basically called winter solstice. Winter solstice. All right, like that. When sun is at its lowest point in the sky all year, like that. All right,
So
kids.
that's after 2 weeks.
Yes, that's about in 2 weeks. That's correct. So you will notice that the day will be very very short on that day, and even in these days you might see that the daylight hours are very very small. Right? Is it clear? Now, this whole thing is happening because of the fact that, let's suppose this is our sun. So around the sun, the orbit of Earth is almost like egg-shaped. Let's put it right there. I want to erase few things. Okay, that's when the Earth, oh, let's not draw this. In fact, let's draw this. Because Earth is a bit tilted like this. So around the year, it just goes like that. Okay, around the year, around the sun, in the whole year, like that. All right, kids. Now these are like dates like 20th March. This is 23rd September. This date is 21st December, and that's 21st June, like that. So when you're moving from March to June, this is the season we call spring. When we go from basically June to September, this is all the summer, and then from here onwards we have autumn, and then after autumn we have winters from December to March, like that. Now I am gonna tell you that the earth is rotating like this, like that, like this, like this, and I'm gonna put some values here, so please look at them very carefully. A, B, H, C, that's D, E, F, and that's G. Okay. I'm going to explain what is happening in this. So first of all, we're going to look at over the paths B, C, and D of the orbit. You might see that the hemisphere northern hemisphere is tilted towards the sun. Okay, you can write this. I just want to try something new. I got a basically a new microphone, so I don't know how it works. Let me try that. Maybe it might do something better. Okay, so plug it in. Okay, well, let's see how it works now. So maybe better, maybe worse. Okay, so it's to tilt it towards the sun. So first of all, remember that this means daylight hours are more than hours of darkness. And this is spring and summer. Now, if you're confused about this northern southern hemisphere, I just want to tell you that if you look at the earth is like tilted a bit. So this section is the northern hemisphere and this section is the southern hemisphere. So as you guys can see that a majority portion of from here to here it's tilted like that towards the sun. So that is the reason that it's hotter here. Anyway, then kids, I'm not sure if you guys can somebody please speak. I don't know if that works.
Yes, sir, we can hear you.
Oh, the issue is that using this mic has one more problem, that it doesn't understand that I have to use the speakers of this system. Let me check out. Just give me 1 second. Now playing from what? Oh, okay. Can you speak now, please? Somebody please speak.
Hello, sir.
Yes, yes, yes. Very good, very good. Now it's working, which is very good. So now the next thing is you guys need to understand that in this region, the southern hemisphere is tilted away from the sun. This means days are shorter than nights, and also this is autumn. Oh my god. And winters. If you guys feel you have any questions, please let me know, okay? Okay. Now what happens at C and at G? This is what we're looking at. So at C, number one, this is summer, solstice, and the northern hemisphere has longest day. Also, you guys need to understand that the southern hemisphere has shortest day. That's how it works, okay? This is the reason you might see that in Australia, we have a different kind of, summers. When we have summers, they have winters and so on, because they lie in the southern hemisphere, not the northern. We people, all of you, amongst also me, we all lie in the northern one. All right, kids. Any questions? Please let me know so I can help you with that. Okay. Now, then at G, what is happening? Let's look at that. G is right here. Okay, 21st December. So in 20 at 21st on 21st December, this is winter solstice. Northern hemisphere has the longest day, and the southern hemisphere. Oh, I wrote wrong. It has to be shortest day. My bad. And southern hemisphere has the longest day. That's something you guys need to remember. Now we're going to move towards A and D, which are like above and below. Let's look at that. So on 21st March and 23rd September, which is at A and D, day and night are equal in both hemispheres. And you guys need to remember that these are called equinoxes. So equinox is basically a time during the year where the night and day are of equal length. All right, kids. Okay, so very nice. So we're done with how Earth, how sun works around us and how we get different seasons. So, Shawez, Ritaj, and Rabia, do you guys understand everything?
Yes, I just wanna copy the stuff down. So could you just please scroll up right now?
Yes, please. Okay. And what about both Mohammeds and Maha? Everything is clear? Okay. And both Hassans and Aisha?
Clear, sir.
Good.
Clear,
All
sir.
right. Thank you, Hassan. And Rema, Amaim, Fraz, you guys, Abdullah, what about you?
Clear, sir.
Amaim, are you there? All right. Well, that's very nice. Okay, good, good. So, is the voice better? Halar is the best judge. He's been noticing that. Or Halar, is it worse?
Sir, it's better.
It's better. Okay. That means it has worked. Okay, that's good. It's very good. All right. Also, while you're copying it, I should better put it on charge because my device is gonna die. Uh-oh. Right. Very nice.
Sir, when it says that the southern hemisphere is tilted away from the sun, should it be like at a point like the others in which it says at G and at A and D, or is it just a fact?
It's a fact. These
Okay.
are all facts. That's why I labeled them, It will
Yeah, yeah,
always
sir. Like I'm just asking that on the other parts there's it says it mentions at C and at G, and so this one just doesn't have a label like that.
because G and C are specific dates, you know. The other parts are different. D and F is the northern hemisphere. That's why. You get it?
Oh, yes, sir.
And A, B, and H are sorry. A, B, and H are northern. D and F are southern. Okay, hemispheres. That's
Okay,
fine.
D and F, yes.
Okay. All right, guys. So the we are gonna finish the syllabus hopefully in the coming week, and when we do, I will be sharing you a PDF. Okay, it's a book that I made. It's a workbook sort of thing. So I'll send it to you before we start the crash course. You guys need to print it down if you're not using anything digital to write, because it will have all the questions and headings and everything there. So it will really help you. You must do that before we meet again in January. Okay. All right. So should I go forward, please? You guys, everybody has written.
Yes, sir.
All right. Now the next thing we're gonna do is the thing where we're gonna learn about phases of moon. Okay, let's do that now. So actually, we got to make a big sun on one side. Obviously, sun is giving us light like that, and the earth is right here. Now, let me use the ruler for this. This is a tricky one to make. Where's the black one? Okay. First of all, let's do it completely vertical. So, oh, no, 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 no. I got to make dotted lines actually. Okay. Then you guys should make a horizontal line on your earth like that. And then you should make diagonal lines. Oh, it's not even passing from there. What has gotten into me? Wait, she passed from here actually. And same goes for the other diagonal line. Just make another diagonal line like that.
Sir, do they need to be dotted lines or can we just make like straight lines?
If you want to make dotted, those are better, but you can make straight lines as well. It's fine.
Okay.
Okay. So generally, what you see is around the Earth that right at this spot, a new moon forms. Okay. Right at this spot, let's put this moon on different places. Okay. Let's put it. Oh, where did my moon go? Just in front of every line, just make a small circle. Only this diagram is important. We don't need to write anything because they can give you phases of moon and then don't be alarmed. Okay. So when the new moon is formed, like this is a new moon, one side of the moon is completely dark because it is lit by sun on the other side, and that's why we do not see the new moon, all right, on Earth. This is when it is about 0 degrees from Earth. Then obviously when it moves to a new location, one side is dark and the other side is quite visible. So that's why we see a moon like this. All right. Then, from our perspective, this is when it is 45 degrees from Earth. Then you see half moon when it is at this location, which is 90 degrees from Earth. And that's when you see half moon lit like that. All right, kids. Then you see this moon. Obviously, the side which is pointing towards Earth is lit by the sun's light. So you see a smaller moon, not as big as the one that you can see in the next phase, and it happens at 135 degrees. And then you see a full moon when it is like the whole section in front of Earth is lit. It's white actually, like that, dark on the other side where the light doesn't reach there. Then you see a smaller moon again when, sorry, this is when it is 180 degree. You can write the angle for this one. This is again 135 degrees. This is 90 degrees. This is 45. Okay, so at this point you see this because the moon is again lit but not as bright because it's not at the 180 degrees. You can't see the whole moon, just the smaller portion of it. And then in this quarter, when you're looking at the moon, it looks like this actually, because that side is lit on Earth. All right, kids. Finally, then at this point, you see this crescent here. Sorry, like that and like this. This is when, again, the moon is shadowed from this and lit from the other side. You see a crescent like that. Anyway, so interestingly, this is a cycle that after every phase, a new phase will begin. So it goes like this. Make the cycle like that. The dark side I've drawn is the one for the movement, right? So remember that. Now they have their own names as well. This one is the new moon. This is called waxing crescent moon. This is called first quarter because now it has moved 90 degrees. Quarter moon. This is waxing gibbous. The spelling of waxing gibbous is Gibbous, moon. Then you have a full moon, and then you get waning gibbous moon. This one is the last quarter because now it will only move 90 degrees for the new moon. And this is waning, Waning, waning crescent moon, like that.
So what's the difference between the waning gibbous moon and the full moon?
Just the the half that you're looking at changes. You see, it's right there because we can see this portion from Earth, and this is because we can see this portion of Earth. Is it
No,
clear?
sir, I was asking what's the difference between the waning gibbous moon and the full moon?
Oh, the size. The size. All right. It basically looks like. Let me write that down as well, so it's more clearer to you. So we can say phase between full and half moon is getting bigger. Do you get it? In size. So as you can see, you can compare the size of this. This is much bigger than this. Do you understand? Then for the other one, duration between each phase. Each phase lasts for around 7 days, I think, because the total is like in a month, lunar month, there are 28 days, right? So around 7 days. And this phase, this is the phase. Okay, I need to rotate it. This is the phase between full and half moon. The moon gets smaller, not physically, it's just the way we look at it, it becomes smaller. So if you one day wake up and you see a very large moon, and then you know that it's basically a full moon, so then the next moon after that will be waning gibbous because it will grow smaller. It will basically not grow, it will become smaller. Get it, you people? Now in your course, the only thing we need to remember is the names of this and the way I've drawn them. Otherwise, you don't need to know anything else. Everything is good. It's good because after the new moon, on both sides of the new moon there will be a crescent moon, waxing and waning. Then half moons, and then waxing and waning gibbous, and then the full moon opposite of it. So you can remember that like that. And just remember, every time a new phase starts, it's at 45 degrees. It has moved 45 degrees with respect to Earth. Understood? like that. Anything else, kids? Okay. When you're done, I want to go to the next. Wait a second, kids. All right, kids, done. Should I go forward, please?
So I'm still doing it.
Sorry, come again.
I'm still doing it.
Okay. Now, after this, we will be going into the real space physics that you were interested in. This was just few things that we had to learn. So we're gonna learn about how the galaxies are formed. We're gonna learn how the stars are formed, and then how do we know the distances between different objects in the
So
universe.
usually
So
those type of questions come in the IG.
yes, from the last year exam, now they will be included.
Alright.
Did you get it? Now, unfortunately, a lot of things were removed to put this in because in A levels it's also included now. That's why they want you guys to learn this before you go into A levels.
Yep, sir, I finished.
Okay. Anybody left? Please let me know. All right. So with that, we are now going towards um, how our galaxy, the Milky Way, by the way, that's the name of the galaxy, so was formed. So basically, this is called the accretion model. Now, obviously, we do not know yet because there's only two exams have happened till now. So it might come in your exam. It was not there before, so you don't know. All right. Anyway, so first of all, you got to write that sun is thought to be formed when gravitational forces of attraction pulled together clouds of hydrogen gas and dust. When it's formed, this is basically the the formation of nebulae. Nebulae is the plural term of nebula. It's basically a dense cloud of gas and dust. All right, kids. Then what happened was number two, our solar system was then formed 5.4.5 billion years ago. This is an estimated age of our solar system. Then the planets were formed from the remnants of the disk cloud of matter left over from the nebulae or nebula that formed sun. All right. I'm going to show you a picture of it, so don't worry. Then the next thing happened. The planets, sorry, not the planets, the interstellar cloud of gas and dust included many elements that were created during the final stages of a star's life cycle. The star's end life cycle happens when it goes under a explosion called supernova. Now, then kids, you guys need to understand that gravity collapsed the matter from nebula it on itself, causing to spin around the sun. Now, remember the gravitational attraction between all the small particles cause them to join together and grow in an accretion process. accretion process. All right, kids. A rotating accretion disk is formed when planets emerged. All right, so you write this down now till I take out the foot of it. Ma'am, I'm going to answer your question. Second, please. Okay. Let's copy this, put it here. Oh, we don't have much space left, so I'm going to put it to the next slide. Okay, that looks okay. The explanation, and then I'm gonna put here, so you can write this down. Let me see what Imam has asked. Okay, now just to explain this a bit, you guys have written this. All right. So kids, now let's have a look. Okay. Now, accretion model is like, initially you have a cloud of gas, like you see, it's a nebulae, and then the dust that you see and the gases that you see collapses, and this dust that forms a certain hotter region and then cooler region at the ends. The hotter region then forms the sun after many, many years later, and the hotter region forms some rocky planets because that's the leftover gas and rock. And then proper planets, this gas that is around it, it also collapses or nearby with other things that forms planets and their moons like this. All right, so this is very simple, nothing to worry about. So tomorrow then we're gonna look at it more in detail. Till then, Imam had a question. Let me just answer that question.